All right, in Trig 3.1, the radian measure today, we're going to learn how to convert from degrees to radians and radians to degrees and what that means. If we were to start with a unit circle, meaning it has a circle with a radius of 1, and if I was to ask you what is the circumference of that circle, the circumference of that circle would be 2 pi times the radius, so it would be 2 pi r. And if I was to ask you how many degrees all the way around a circle, almost every one of you would say, well, that's 360 degrees. And so hence this is where they get the 2 pi radians equals 360 degrees. If I was to divide both of these by 2, notice that I would get pi radians is 180 degrees. And that's what we're going to be using for our conversions as we go on to the next slides. So convert 108 degrees measures to radian measure. So we just said that pi radians equals 180 degrees. So if I took this 108 and I multiply it by pi radians over 180 degrees, those 2 degree symbols would cancel. Then I just need to reduce the fraction 108 over 180. And so 108 divided by 180 would reduce to 3/5, and notice I still have the pi in that answer. If I had 325 7/10 of a degree, again we would times by pi radians and divide by 180 degrees. Again, I want the 2 degree symbols to cancel. And this one here probably wanted a decimal answer on the test or the homework. So you would actually literally just use the pi symbol in your calculator. You guys would do second pi to get there. All right, now we're going to go the other direction. So I'm going to convert from a radian measure to degrees. We just said pi was equivalent to 180 degrees. So if I was to multiply this by 180 degrees over pi, it's really multiplying big old fancy 1. See, now the pi's would reduce, and therefore now I need 11 times 180 divided by 12, and that's how many degrees that would be. Negative 2 and 92 hundredths converted to degrees. See, notice there's not a degree symbol on this, so that means this is in radians, even though there's not a pi symbol there. Okay, so if there's not a degree symbol, that is understood radians. I have to write a degree measure for it to mean a degree. Now, since I want to convert that radian to a degree, I would want to multiply by a degree and divide by the radians. Therefore, the radians cancel. So I have negative 2 and 92 hundredths times 180, and then divide by pi. It says find the value of each function. So the cosine of 5 pi 6. So the easiest thing here to do actually would be to convert this to a degree measure. I know pi is equivalent to 180 degrees. So if I think about pi 6, 180 degrees divided by 6, well, that would be 30 degrees. 30 degrees times 5, that'd be 150 degrees. So that's the first thing I actually would do, is I would actually convert that, and now I need the cosine of 150 degrees. Now we need to think about what quadrant is that in. So 150 degrees would put me in quadrant 2 with a reference angle of 30 degrees. By my statement, all students take calculus, the cosine here would be negative. So therefore I know this answer would be equal to negative whatever the cosine of 30 degrees is. And then I use my 30-60 right triangle. And so here's a 30-60 right triangle. The cosine of 30 degrees would be radical 3 over 2. So that answer was negative radical 3 over 2 for A. All right, problem B wants the cotangent at 3 pi 4s. So 180 degrees divided by 4, because that's basically what's going to happen here. See, the pi's are gone. They reduce, they simplify to 1. 180 divided by 4, and 90 degrees divided by 2, so 45 times 3. That's how I could get that angle measure quickly. And again, these would be all basic calculator on your test for this part of the assignment. Now I need the cotangent at 135. 135 is going to be in quadrant 2 with a reference angle of, hopefully you're thinking 45 degrees. So again, that was going to be 135 degrees from the positive x-axis around to it, 135. Reference angle up against the x-axis. Now cotangent is the reciprocal of tangent. All students take calculus. So all students, sine's positive, that means tangent's negative. So this is equal to negative cotangent of 45 degrees. Cotangent is the reciprocal of the tangent. So on my right triangle, 45, 45, 90, tangent would be 1 over 1. Well, the cotangent would still be 1 over 1. And I have that negative in the front, so it would be negative 1 is my answer. Right, now I need the secant of 5 pi thirds. So pi is, again, equivalent to 180 degrees. Divided by 3 would be 60 degrees. Times 5 would be 300 degrees. So I need the secant at 300 degrees. 300 degrees would put me in quadrant. Hopefully you're thinking 4 with a reference angle of 60. So 300 degrees from the positive x-axis around to that. That would be 300 degrees to there. That leaves me 60-degree reference angle. Secant is the reciprocal of cosine. All students take calculus. The cosine's positive. Therefore, the secant is positive there. So I'm just going to need to take the reciprocal of the cosine of 60 degrees. We go back to this picture. The cosine of 60 degrees is 1 over 2. So its reciprocal would be 2 over 1. So again, you took your radian measure, you converted it to degrees by multiplying by 180 degrees over pi, figure out which quadrant does it fall in, and what reference angle is it. To use your all students take calculus to determine if it's negative or positive and rewrite it in terms of the reference angle, and then go ahead and use your two triangles to get this. So obviously problems like this would all be with a basic calculator, no scientific calculator for this. That ends your lesson 3.1. I want you to start with the multiples of 3 and then come back in and finish up that assignment. Thank you. Have a great day.